This is section 2.10 in your textbook on and/or inequalities. So we're going to talk about inequalities containing and then we'll talk about inequalities containing the word or. So compound inequalities containing the word and. The word and means both. If you're going to have ham and cheese, you're going to have both. So and means both inequalities must be true for the solution interval. When you graph the inequalities, the arrows must overlap. So we're looking for where they overlap, where they cross. If the arrows face away from each other and do not overlap, there is no solution. If both arrows face the same direction or point towards each other, only the overlapping section is the solution interval. So we're going to look at the different options of how your answers can look, and then we'll get into actually solving these. So if the inequality already solved says x is less than 4 and x is greater than -1. So we're going to graph both of those statements on the same number line. We have 0 here, 4 over here, -1 over here. Remember, infinity's over here, negative infinities to the left. So x is less than 4, looks like this, and goes this direction. You might want to do this in a different color, it's up to you. I'm going to go ahead and trace this over in one color. And then if you want to use the second color for the other one, it kind of helps you see it. So x is greater than -1, greater than would be this way, going this direction. So what you're looking for is the section where the two lines overlap. So the two lines overlap from here to there. Only that part, they're both true. They both have to be true. They're only true in that part. So your solution interval, in interval notation, we also call this the solution interval, is only between -1 and 4. Only between those 2 points are both lines true. Let's look at the second one. It says x is less than or equal to 4 and less than or equal to -1. Again, you might want a couple different colors here. X is less than or equal to 4. Here's 4 again, less than or equal to is a bracket going this way towards -infinity. And it says, and x is less than or equal to -1. So here's -1, again a bracket in the less than direction. And you want to draw your arrows all the way across the given number line so you can really see it. And again, we're looking for where they overlap, where they're both true. So they're only both true here. Over here, only one of them is true. They're both true between -infinity and -1. And we can use a bracket to match that bracket. They're only both true between -infinity and -1. Let's look at the next one. It says x is greater than 4. So here's 4, parentheses, towards the greater than direction. And x is less than -1. Less than goes to the left, arrow to the left. Notice on this one there is no overlap. There is no place where they're both true. So if there's no overlap, then there is no solution. And finally, we have x is greater than or equal to 4. Here's 4, greater than or equal to goes this way towards infinity. And x is greater than -1. So greater than -1 goes here, arrows going this way also towards positive infinity. Again, we're looking for where they're both true. Over here they are both true, over here they are not. So they are both true from 4 to infinity. So the graph here is extremely helpful to getting your solution interval. Without the graph, it's really hard to visualize. So always draw your graph, even if the homework doesn't ask for it. Draw your graph so you can see your solution interval. And again, you're looking for where they overlap. So let's look at some examples here. We're going to solve it, we're going to graph it, and then we'll state our solution interval. So we have x minus 7 is less than 2, and 2x plus 1 is less than 9. So I'm going to solve this one. X is less than 9. I'm going to solve this one. You should get x is less than 4. So I'm going to graph x is less than 9. I'm also going to graph x is less than 4 on the same number line. So 9 is over here, 4 is over here. You can always put 0. I didn't put 0 on these, but 0 being in the middle is helpful so you can get a good sense of where things go. So 0 would be over here. X is less than 9. Looks like that. X is less than 4. Looks like that. And we're looking for where they're both true. And that would be from negative infinity to 4. They stop being both true after 4. So it's only from negative infinity to 4 that they're both true. All right, let's look at example 2. Again, you can pause the video at any time and try it on your own, or you can just continue to follow along. We're going to subtract 3 here. X is less than 5. We'll go ahead and solve this guy. X is greater than 2. So we have x is less than 5 and x is greater than 2. Here's 2, here's 5. Greater than 2 goes this way. Less than 5 goes this way. They're only both true in the middle between 2 and 5. Example 3. We go ahead and solve. Divide by 2. 0 divided by 2 is still 0. Go ahead and solve this guy. You should get x is less than or equal to negative 2. So x is greater than 0 and less than or equal to negative 2. 0 is a perfectly fine number. Students tend to panic when they see 0. 0 is just another number. So x is greater than or equal to 0. That would be a bracket to the right. And x is less than or equal to negative 2. Less than or equal to would go this way. There is no overlap, so there is no solution because there's no overlap. And last but not least, example 4. Divide by 4. X is less than or equal to 0. Solve the other one. You should get x is greater than 2. So x is less than or equal to 0 and x is greater than 2. So 0 is here. Less than or equal to 0 goes this way. And then 2 greater than 2 goes this way. No overlap, so no solution. So the solution is only where they overlap. And again, feel free to use 2 different colors. Our brains react better with color, and so color can help you really see that overlap. So those are and. And is both. And is both. They have to overlap. Let's look now at or. Compound inequalities containing the word or. Or means one or the other or both. Now normally if I said ham or turkey, you could only choose one, but in mathematics, or means one or the other or both. Usually kids like to pick both, so that's okay in math. It says when you graph the inequalities, if the arrows face away from each other and do not overlap, that says that should say your answer is a union of the two intervals. And we'll talk about what a union looks like when we get to it. It's a union of the two intervals. If the arrows face each other and overlap, then the solution is all real numbers. If both arrows face the same direction, then they combine to become one interval. Again, we'll look at these different choices and kind of see how they play out on the number line, and then we'll do some solving. So this one says x is less than or equal to -2, and let's use our colors to kind of help us see it. Less than or equal to -2. So here's -2, less than or equal goes this way. And if it helps, you can put your negative infinity. Or x is greater than or equal to 3. So here's 3, greater than or equal to goes towards this way. So they face away from each other, they do not overlap, so your answer is a union of the two intervals. So you'll write the first interval, negative infinity to -2 with a bracket. You're going to put a capital letter U, and then you're going to write the other interval, 3 to infinity. So this curved U, it's not really the letter U, it just looks like a U, it's more of a horseshoe kind of curve, is the symbol for union. It's kind of like just putting them together. There's a gap in between them, the U kind of horseshoe shape connects them. That's the symbol for union. Let's look at the second one. We have x is less than -2, so parentheses this time, or x is less than 3. Here's 3. You'll notice this time the arrows face the same direction. So if both arrows face the same direction, you combine them to become one interval. So it's kind of like you smash these two together and they just become one interval altogether. So it goes all the way from negative infinity, continues, goes past -2, keeps going all the way to 3. So it's just like the yellow arrow got combined into the blue arrow, and it's all one arrow now. Let's look at the third one. X is greater than or equal to -2. So greater than or equal to goes this way. Or x is greater than or equal to 3. So here's 3, another bracket, greater than or equal to goes this way. So they're facing the same direction. Again, you kind of smash them together, they become one interval. And so it's just one continuous interval from -2 to infinity. So the 3 just kind of gets smushed and becomes one big interval. Alright, let's look at the last option here. X is greater than -2. So greater than goes this way. Or x is less than 3. Less than 3 goes this way. So they're facing each other and they overlap. Again, you kind of smush them all together and it just becomes one interval, and it runs all the way from negative infinity to infinity. So it's just one big never-ending interval of all real numbers. So it's just a non-stop interval. So let's look at some of the solving. Again, you can try these on your own and then play it back to see how you did, or you can just continue to follow along. Let's see, we're going to go ahead and solve, and then we'll graph and get our solution interval. So we get x is less than 2, or going through the solving process here, x is greater than 3. So x is less than 2, here's 0, here's 2, less than 2 goes this way, or x is greater than 3, 3 goes this way. So our interval is going to go negative infinity to 2 with a u for union, and then 3 to infinity. So if it's broken apart, that's okay for or, because or means one or the other. Let's solve example 2. Did not give you guys enough space on these, sorry about that. X is greater than negative 1, then let's solve here. X is less than negative 5. Alright, so greater than negative 1 goes this way. Less than negative 5 goes the other way. So again, we have a union from negative infinity to negative 5, union negative 1 to infinity. So you just have to be really good at going from the graph to the interval notation. Again, that goes back to the previous section. Just practice that interval notation. Alright, on the next one, we're going to add 3. We'll get 5x is less than or equal to 15. You should get x is less than or equal to 3. And then here we'll subtract 1. X is greater than or equal to 4. So you're always going to get two separate answers for and or. You can graph them both, and then you see what happens. So less than or equal to 3 goes this way. Greater than or equal to 4 goes that way. Again, we have another union here. Union 4 to infinity. They're not always all unions. These just happen to work out that way. All right, and last but not least, example 4. Negative 2x is less than 2. When you divide here, you're going to be dividing by a negative. So turn your sign the other way. So it was less than, now it's greater than. Here we'll just divide by 6. We have x is greater than negative 1. Greater than goes this way. And x is less than 0. Less than goes that way. They overlap, and you just kind of smush them together, and it continues on forever in both directions, from negative infinity to positive infinity, or all real numbers. So you just solve each one, graph each one. It's going to turn out to one of these 4 options, and you write your interval notation accordingly.